All right, welcome. So we're going to do 3.2 or 3.1.2. So this is basic output programming. All right, so here's our test bed. We're going over to this part. This part basically says that there is block-based coding, and then there's also text-based coding. So for the block-based one, it's very visual. You can forget about the syntax, but also there's benefits to doing C++ and Python because it's very real-world application. If you know these skills, then you can transfer it. It's a professional language. All right, so basically you're going to open up the VexCode V5. You're going to connect your brain to the computer using a USB, and then you're going to turn it on. All right, so some of you may have to update the brain, but I just connected it, turned on the power, and my brain is green. It's working, looks good. If you need to update the brain, there is a force update, so you can go ahead and do that. Same might go for the battery and some of the motors. So next thing we're going to talk about is basically saving your project. So you can go over here, do File, and then Save As, and you can save it under different parts of the project. So I'm actually go ahead and put this as Save As, and it's 3.1.2. I'm going to call this Basic Output Input. All right, so next part it talks about is there's different slots that you can put code in. So if you can load up 8 different programs in there, and you can select it on the brain. So I'm going to have this in code slot number 1. All right. So for this one, for part 7, we're basically looking at LED lights and how we're going to connect it and make our LED light run on our program. All right, so basically we're talking about event handlers. We have a when started event handler. Okay, we went over functions. Basically, this is defining a function, DEF. When started, this is defining a function. And whenever I call it, whenever I put down when started, it runs it. This is the function, it runs this part of the program. Okay, so an event handler is pretty similar. You're going to define an event. Basically, there's a function. It's going to turn on. We can even put this even closer. It's going to set the light on optical. It's going to turn it on. So how does it know when that's going to happen? I could put it down here so it runs automatically, or right here I can put down bumper in port D. When it's pressed, start this event. And this is when it's going to run this function. So basically, once I press this bumper, it's going to start this entire event. All right, so here's another event handler. Let me write the code for that one. All right, so we're going to go over to events, and then it's when brain timer event. So that is basically it's calling the event. And what do we want to happen? Well, we need to define. All right, so right here, it's defining the function event timer. Once that happens, the servo will set position to 40 degrees. What's the event? The brain timer event. It's going to trigger this function at 2 seconds. So that's just a couple of different examples of how to get an event handler working and how to get a function just to run. Okay, so it's either you call it right here or you have an event happen that makes that function run. Okay. For right here, it's saying you want to have when started, set LED to on. Okay, let's see, when started. Let's copy this over here. Right, so now basically when started, when this function is called, LED light will turn on. Okay, so you're going to download and press run. And basically my LED light is turning on right now. All right, so basically right here, it's saying, now that you've done the light, let's do servos and motors. So right now, you're going to go ahead, when started, spin servo to position 100 degrees. It says basically there should be a 50 degrees in there already. You're going to make 100. So this is for the block-based one. So let's do this for Python. Okay, so let's delete this one. Let's go up to motion, and we have a servo. Put that in here. Okay, and change this to 100. Perfect. Go ahead, download this, and then run it, and then see if the servo turns to 100 degrees. And it just turned to 100 degrees. Perfect. All right, so it's saying change the value from 100 to 0. Run the program again. And then next part is you're going to have it go from 100, wait 3 seconds, then go to 0. All right, so let's go down. Here is wait. And you're going to change it to 3 seconds. And then you're going to do servo to 0 degrees. Oh, that's not good. That's out of the function. We need to get it back in the function, and we're going to go to 0 degrees. So download and run. And I'm running it. And you should hear your servo run. So at this point, it's saying stop. And actually, here's what I want you to do is take a screenshot, and you're going to share it. I'm going to put a link in, and basically this is how I'm going to verify people are doing their work. All right, and then we're going to do this part right here. Basically, here's some questions for you guys to answer. Okay, so it says program, go to 50 degrees, wait 2 seconds, or for 2 seconds, go to 50 degrees. Go to 0 degrees for 3 seconds, 50 degrees for 2 seconds, 100 degrees for 3 seconds, 50 degrees for 2 seconds. Okay, let's get working on that. So there are 5 different events. So let's do 5 different versions of this code. 1, 2, 3, 4, 5. Perfect. All right, so 52, 50 for 2 seconds, 0 for 3, 0 for 3, 50 for 2, 50 for 2, 0 for 3, 0 for 3. Okay, perfect. All right, so download this one and go ahead and run it also. All right, so for part 3, basically it's saying that smart motors have more options than 3-wire motors. So you can always use a help block to see what are some different things that motor can do. All right, so as we mentioned earlier, for the drivetrain, basically it connects the 2 motors. It's saying drivetrain move forward. It knows that those 2 motors are working together. So let's go back up to configuration, and the reason why I'm doing this is saying they're looking at controlling 1 motor at a time. Okay, so you can't really do that with the drivetrain, but let's see if we can figure out what to call this. It looks like left drive smart, right drive smart. So those are the 2 that we're going to be working with. Okay, so if I type in left, and basically it already comes up. What do we want it to do? It's saying we want it to spin up. Okay, so let's see if we can do this. Spin action. And it looks like we have to use forward. All right, so let's get all this code out of here. And that needs to be indented. And now it knows it's part of that function now. So it's saying right here, the default names are forward or reverse, but if you move something up or down, basically calling it up or down. So we can use this as a pulley to pull up, like I think we have one project is a freight elevator. All right, so right now it's saying write some pseudocode in there. So I'm actually, all right, so here's my pseudocode. It's saying make the left motor spin forward for 3 seconds at 50%, stop, then spin backwards full speed for 3 seconds before stopping. Make the right motor spin backwards 180 degrees, then spin to a position of 100. All right, so we have right here, we have the right drive motor spin to position 180 degrees, wait until it equals true. So basically it's saying the wait until true is stay with this code until it equals 180. Once it equals 180, you can move on to the next section. Okay, so it says wait for 3 seconds, then go on to this portion of the code. Right drive motor spin to 100 degrees. Wait until this statement is true. It's at 100 degrees because, right, it has to take some time to go from 180 to 100. Wait until that's true, then go on to the next portion of the code. All right, so I actually had to go and delete the drivetrain and add in individual motors in there to make this work. So motor, put that in place 10. Let's make this one go fast. Let's do motor, place 20. I'm sorry, that'll be a low RPM and a high torque. So this one will have a very high torque on it. So let's change around some of the commands. 10, 10, 10. 10, motor 20, motor 20. All right, after a little bit of playing around, this code finally worked.